Have you ever looked up at the night sky and realized that thousands of machines are flying above your head right now? I'm not talking about airplanes. I'm talking about satellites. These incredible pieces of tech are constantly circling our planet. It's helping us navigate with GPS, watch live TV, and even scroll through the internet. But it brings up a huge question that most people never think about. Why don't they just fall back down to Earth? The answer is both simple and totally mind-bending. Satellites are actually falling toward Earth every single second. Gravity is pulling them down constantly, just like it pulls you down when you jump. But satellites have one crucial advantage that keeps them from crashing. They are moving forward incredibly, ridiculously fast. When a satellite is launched, rockets don't just send it straight up. They push it sideways at unbelievable speeds, around 28,000 kilometers per hour. At that speed, as the satellite falls toward Earth, the planet itself curves away underneath it. So instead of hitting the ground, it just keeps missing it. Imagine standing on a giant mountain and throwing a ball. If you toss it gently, it lands nearby. Throw it harder, and it travels farther. Now, imagine you could throw that ball so incredibly fast that the ground curves away before the ball has a chance to land. It would just keep falling around the planet forever. That is exactly how orbit works. Scientists figured this out hundreds of years ago. If something moves fast enough sideways while gravity pulls it down, it will continuously fall around Earth instead of into it. That continuous falling motion is what we call orbit. So, satellites aren't just floating up there. They are in a constant state of falling, moving forward so fast that they keep missing the ground. It's like being stuck in a never-ending fall around the planet. But getting a satellite into that perfect orbit is extremely difficult. Rockets have to lift it high above the atmosphere and then accelerate it to those extreme sideways speeds. This takes an enormous amount of energy and precise timing. A tiny mistake in speed or direction could send the satellite crashing back down or drifting off into deep space. Once in orbit, satellites follow carefully calculated paths. How high the satellite is determines how fast it needs to go. Satellites in low Earth's orbit, just a few hundred kilometers up, are closer to Earth's gravity, so they have to travel very fast. Many of them circle the entire planet in about 90 minutes. These are often used for things like Earth observation, scientific research, and taking those detailed photos of weather systems and cities you see online. Higher up, you have satellites in medium Earth orbit. These are the workhorses of navigation systems like GPS. They orbit much higher and take several hours to go around the planet. But one of the most fascinating orbits is called geostationary orbit. These satellites are way out there, about 36,000 kilometers above the equator. At that specific distance, the satellite takes exactly 24 hours to complete one orbit, which is the same time it takes for Earth to rotate once. Because they're moving at the same rotational speed, the satellite appears to stay fixed over the exact same spot on Earth. This is perfect for TV broadcasting and communication networks. Now, space isn't completely empty. Even high up, there are tiny traces of atmosphere that create a small amount of drag, slowly causing satellites to lose speed. When a satellite slows down, gravity starts to win the tug-of-war. To prevent this, many satellites have small thrusters that give them a gentle push to stay at the correct speed and altitude. Another huge challenge is space debris. Decades of launches have left behind old rocket parts and fragments from collisions. Even a tiny paint chip moving at thousands of kilometers per hour can cause catastrophic damage. So satellites are carefully tracked and sometimes have to perform maneuvers to dodge junk. Despite these challenges, satellites have become essential to modern life. Your phone's GPS relies on a network of them constantly sending signals. Whether satellites track storms and help predict natural disasters, and communication satellites relay everything from phone calls to internet signals across the globe, connecting even the most remote areas. All of this incredible technology depends on that same basic principle, the delicate balance between gravity's pull and forward speed. So the next time you look up at the night sky, remember that thousands of satellites are racing around the planet. They aren't floating. They're falling forever, perfectly balanced in a dance that keeps our modern world connected. Thank you for watching today's video. Don't forget to like and subscribe if you want more 5-minute educational videos. Please leave your suggestions below on what you would like us to cover next.